So when we're using percents to describe change, there are two basic ways we could describe the change of a population that has risen from 10,000 a decade ago to 150,000 today. We could talk about it rising by 5,000 people. That would be the absolute change. Or the increase of 5,000 people was 50% of the starting population, so that we're saying the relative change is 50%. Relative change is going to be much more useful when you're comparing two different things. So for example, if we were comparing enrollment at Brightpoint and Reynolds from different years, it's more useful to look at the relative change than the absolute change, because there could be a different number of total students at each of those colleges. So the absolute change describes the actual increase or decrease from a reference value or the starting number to the new value. So our absolute change is going to equal the new value minus the reference value. Some people remember this easier as just new minus old. The relative change is a fraction, which it should be written here as a fraction, that describes the size of the absolute change in comparison to the reference value. So our relative change is going to be the new minus old, the new value, minus the reference value, divided by the reference value, times 100, because we're getting this as a percent. Or you can remember it as new minus old divided by old. And here it is again in a nice pretty purple box. During a 6-month period, Lunar Industries stock doubled in price from $7 to $14. What were the absolute and relative changes in the stock price? So our absolute change would be $14 minus $7, a $7 increase. The relative change, we have new minus old over old times 100. So we're going to get 14 minus 7 is 7. Divided by 7 is 1. 1 times 100 is 100% increase. So when something were to double in value, it would be an 100% increase from its prior value, which is exactly what we're seeing here. We went from $7 to $14. So that's a 100% increase. Some people think, oh, it doubled, so that has to be 200%. That's not correct. If the car dropped from $15,300 in value to $13,700 in value over the last year, what percent decrease is this? So my round to the nearest hundredth, my new value is 13,700 minus my old value divided by my old value times 100%. So 13,700 minus 15,300 divided by 15,300. You will here get a negative number. We don't need to include the negative because we're talking about a percent decrease. So I'm going to say with the times 100, I'm moving the decimal twice. It is a 10.46 because I'm looking at the 5 here, and I've got to see is that number more than 5 or greater than the 5 goes up to a 6. So it's a 10.46% decrease. Percentages are also commonly used to compare two numbers. So suppose we want to compare the price of a $50,000 Mercedes to a $40,000 Lexus. The difference is $10,000 if we just take the $50,000 minus the $40,000. But let's express the difference as a percent of the Lexus price. So they already did. This isn't really new minus old because there isn't a new and an old. This is just a comparison of two things. So they did Mercedes minus Lexus. Divided by Lexus to get that the Mercedes costs 25% more than the Lexus. The reason that you would want to do something like this is because looking at it as the straight numbers isn't always meaningful when the numbers can be so large or so little, right? If I'm looking at the difference in something that costs $20 versus $45, well, that's $25, which is pretty significant when I'm looking at things that are under $100. But when you're looking at, say, two houses that are, maybe $50,000 different, well, it depends on what are you spending on the house to decide, is it worth the difference? So since we're comparing the Lexus price, we say that the Lexus price is the reference value. Notice that the reference value follows the word than. Mercedes price is the comparable value, and we can find the absolute and relative differences, just like we defined absolute and relative change. So that's pretty much all there is to comparisons, except there's no particular reason why we choose one item as the reference value. We could have just as easily chosen the Mercedes as our reference value, in which case we would have gotten an absolute difference of negative $10,000 because the Lexus costs $10,000 less than the Mercedes. And the relative difference would have been negative 20% because the Lexus costs 20% less than the Mercedes. So now we have two ways to talk about the difference in these car prices. The Mercedes costs 25% more than the Lexus, or the Lexus costs 20% less than the Mercedes. So the absolute difference is the actual difference between the compared value and the reference value. So our absolute difference is going to be absolute difference equals our compared value minus the reference value and our relative difference is going to be our compared value minus our reference value divided by our reference value times 100. So these are the same formulas as you saw above, but we didn't put new minus old and new minus old over old because there's no new and old. So don't feel like I'm throwing multiple different formulas at you. Notice that they're identical. There's just no new and old. But if you want to be like, this one's my new one, this one's my old one, that's fine. As long as you keep, the important part here is that the reference value is subtracted and then divided in our relative difference. And also just be careful to keep them straight. So if you're calling the Lexus the reference value, then it needs to be the reference value in both equations. So both statements are correct, yet they contain different percentages. So it's be careful to figure out which one's the reference and which one's the compared value. So if a quantity A is P% more than quantity B, then quantity B is 100 divided by 100 plus P% less than quantity A. So what in the world did I just say? If quantity A is P% more than quantity P. So we had that where quantity A, the Mercedes, is 25% more than quantity B. That was the Lexus. So quantity B, the Lexus, is 100 divided by 100 plus, that P that I'm talking about is the 25, which is 100 divided by 125, 0.8% less, but we need to subtract it from 100. So 100 minus 0.8, 0.2, or 20% less than the Mercedes. Example 15, recent data showed that California ranked first among the 50 states in average income, about $68,900 per person, and West Virginia ranked last, about $46,600 per person. So how much lower is the average income in West Virginia than in California? Remember up here, we said the reference value follows then. So how much lower is the average income in West Virginia than in California? So California is our reference value. So our absolute difference is going to be our West Virginia number, which is 46,600, minus our reference value, which is 68,900. 46,600 minus 68,900 is negative 22,300. So the average income is $22,300 less in West Virginia than in California. Let's go ahead and find the relative difference because we just found the absolute difference. So we would do the West Virginia minus California over California. Well, we already did West Virginia minus California. That was what we did in the first step. We got the -2,300 divided by the California income was 68,900. And I get a relative difference of -0.32365.7. So that is a difference of, move the decimal 2 points because we are multiplying by 100, 32.37, notice the 6 goes up to a 7 because of the 5 after it, percent. What does that mean? Sorry, I should have kept the negative there. That means that the average income in West Virginia is 32.37% lower than in California. How much higher is the average income in California than in West Virginia? So now we're just flipping them. Now we're saying that West Virginia is our reference value this time. So we're doing the same problem, but we're going to flip the numbers. 68,900 minus 46,600 tells me that we've got $22,300 more on average in California than in West Virginia. And our relative difference would be that number, the 22,300 divided by the 46,600. And I get 0.47854. I'm going to multiply by 100, which means that I move the decimal 2 places. 47.85. The 5 does not go up because the 4 after it is less than 5. So 47.85% higher in California than West Virginia. So note that our absolute differences in Part A and B are the same, except in Part A we had a negative absolute difference. In Part B it was positive. The relative differences are not the same. Example 16, the life expectancy at birth of all Americans in 2020, 78.6 years, is what percent greater than the life expectancy of all Americans in 1900? 47.3 years. Wow, that's a huge change. Remember we said that the reference value comes after than, so our reference value is our 1900. We're talking about percent greater, so we've got to be just doing the relative difference. So our relative difference is going to be the 78.6 minus 47.3 over 47.3 times 100%. 78.6 minus 47.3 divided by 47.3 is 0.66173 times 100%. I'm going to move the decimal 2 places, and I get 66.17%. So the life expectancy is 66.17% greater than the life expectancy of all Americans in 1900. Example 17, the marriage rate in the United States in 2018, 6.5 marriages per 1,000 people, is what percent less than the marriage rate in 1990? 9.8 per 100 people. Per 1,000 people. The per 1,000 people part isn't important. It's just that they match, that we're using the same units here. And we've got less than the marriage rate in 1990, so that means that the 1990 rate is going to be our reference value. So 6.5 minus 9.8 divided by 9.8 times 100%. 6.5 minus 9.8 divided by 9.8. I've got negative 0.3367 times 100%. Move the decimal 2 places. And there was a 3 after here. So I've got 33.67, which I keep as a 7 because of the 3. And it is negative, which is good because my question says percent less, so I should get a negative number. So it's 33.67% less. Now, when it says percent less after it, I'm not going to include the negative in my answer because the percent less part is already accounting for it being a negative number. If I say it's negative 33.67% less, well, now I've got 2 negatives on there. I've got negative percent less. That's really making it like a percent more. So be careful about that. Of versus more than. Consider a population that triples in size from 200 to 600. We could state this change as a more than, so the new population is 200% more than the original population. So here we are stating the relative change. So we've done 600 minus 200 divided by 200 times 100 gives me 200%. Or we can use of, the new population is 300% of the original population, which means it's 3 times the size of the original population. So here we're just looking at the ratio of new to old. New divided by old, 600 divided by 200 gives me 300%. Both of these statements are true. Example 19, according to U.S. government statistics, the percentage of adults with landlines in their household fell from 90% in 2004 to 39% in 2020. Describe the absolute and relative change. So the absolute change would be 39% minus 90%, which is negative 51%. So 51, how did we word it up here? The absolute decrease is 51 percentage points. But the relative change we've got 39 minus 90 over 90 times 100 is going to be negative 56.67%. So we have a relative decrease of 56.67%.